Where did everything come from? How did it all begin? These are questions humans have pondered for centuries. Today, the leading scientific explanation for the origin of the universe is the Big Bang Theory. It's a mind-boggling concept, but stick with me as we explore the incredible journey of our universe. The Big Bang Theory suggests that the universe as we know it began from an extremely hot, dense state, smaller than an atom, about 13.8 billion years ago. From this tiny point, the universe expanded and cooled, eventually giving rise to everything we see today: stars, planets, galaxies, and even you and me. The Big Bang Theory isn't just a guess. It's supported by a wealth of scientific evidence, from the light left over from the early universe to the way galaxies are moving away from one another. It's a story still being written, with new discoveries constantly refining our understanding. So, buckle up, get ready to expand your mind, and let's explore the amazing story of the Big Bang. When we hear the word bang, we usually picture an explosion, something happening at a particular location with stuff flying outward. It's a sudden, violent event that sends shockwaves through the air, scattering debris in all directions. But the Big Bang wasn't like that at all. It wasn't a single point in space where everything exploded outward. Instead, it was the rapid expansion of space itself, happening everywhere at once. It wasn't an explosion in space, it was an explosion of space itself. Imagine the fabric of the universe stretching and expanding, carrying galaxies, stars, and planets along with it. Imagine a tiny balloon with dots drawn all over it. These dots represent galaxies or clusters of galaxies. Now picture that balloon inflating. As the balloon expands, the dots move farther apart from each other. This is a simple analogy to help visualize how space itself expanded during the Big Bang. As the balloon gets bigger, the dots move farther apart. This is similar to how galaxies move away from each other as the universe expands. That's similar to what happened during the Big Bang. The universe didn't explode into pre-existing space. Rather, space itself was expanding, and everything within it was moving apart. Space itself expanded, and everything in the universe moved along with it. This expansion is still happening today, with galaxies continuing to drift apart. And it wasn't just a slow and steady expansion. In the first moments after the Big Bang, the universe expanded at an incredibly rapid rate. In the first fraction of a second after the Big Bang, the universe underwent a period of rapid expansion called inflation. During this brief period, the universe grew exponentially, doubling in size many times over in a tiny fraction of a second. This incredible growth spurt stretched the universe to an enormous size, smoothing out its initial wrinkles and setting the stage for the large-scale structure we see today. It was during this time that the seeds for galaxies, stars, and planets were planted. The Big Bang wasn't a chaotic event either. It followed physical laws, just like the universe does today. These laws governed the behavior of particles and energy, leading to the formation of the complex structures we observe in the cosmos. By studying these laws and the echoes of the Big Bang, we can piece together the amazing story of our universe's birth. Scientists use observations of cosmic microwave background radiation, the afterglow of the Big Bang, to understand the conditions of the early universe. This radiation provides a snapshot of the universe when it was just 380,000 years old, revealing information about its composition, temperature, and density. By analyzing this data, astronomers can trace the evolution of the universe from its fiery beginnings to the vast, complex cosmos we see today. The story of the Big Bang is a testament to the power of scientific inquiry and the human desire to understand our origins. It's a story that continues to unfold as we explore the universe and uncover its many mysteries. So the next time you hear the word bang, remember that the Big Bang was not just an explosion, but the beginning of everything we know. It's the reason we have stars to gaze at, planets to explore, and a universe full of wonders to discover. Before the Big Bang, there was no space, no time, no matter as we know it. Everything was concentrated in an infinitely dense point called a singularity. What existed before the singularity? That's a question that even our current understanding of physics can't answer, but from that singularity, the universe exploded forth. In the first fleeting fractions of a second, the universe was unimaginably hot and dense. It was a seething cauldron of energy, where temperatures were so high that matter as we know it couldn't exist. As the universe expanded and cooled, this energy began to transform. First came fundamental particles like quarks and leptons, the building blocks of everything we see around us. These particles constantly collided and interacted in the extreme conditions of the early universe. This period was a time of incredible change and evolution, where the fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces were all intertwined. It was from this chaotic soup that the universe as we know it would eventually emerge. For the first 380,000 years after the Big Bang, the universe was a hot, opaque fog. This period is often referred to as the Cosmic Dark Ages, a time when the universe was filled with a dense, glowing plasma. The intense heat and density meant that particles were in a constant state of interaction. Light couldn't travel freely because it constantly interacted with the dense soup of protons, neutrons, and electrons. These particles were so tightly packed that photons, the particles of light, were continuously scattered and absorbed, making the universe opaque. Imagine being in the thickest fog imaginable. You wouldn't be able to see your hand in front of your face. This is what the early universe was like, an impenetrable fog where light was trapped and couldn't move freely. But as the universe continued to expand and cool, a crucial transition occurred. The expansion caused the temperature to drop, and the once chaotic environment began to calm down. Protons and electrons, once zipping around independently, combined to form the first atoms, primarily hydrogen, the simplest element. This process was a significant milestone in the evolution of the universe. This event, known as recombination, had a profound effect on the universe. During recombination, the free electrons were captured by protons to form neutral hydrogen atoms, reducing the number of free electrons available to scatter light. With fewer free electrons to scatter light, the universe suddenly became transparent. This transparency allowed light to travel unimpeded for the first time. Light could finally travel freely across vast distances. This marked the end of the Cosmic Dark Ages and the beginning of a new era where light could illuminate the universe. This first light, released when the universe was just 380,000 years old, still exists today. It has traveled through space for billions of years, carrying with it a snapshot of the early universe. We observe it as the Cosmic Microwave Background, or CMB, a faint afterglow that permeates all of space. The CMB is a relic of the early universe, a time capsule that provides a glimpse into the conditions that existed shortly after the Big Bang. The CMB is a treasure trove of information about the early universe. It contains subtle variations in temperature and density that reveal the distribution of matter and energy in the early cosmos. By studying its subtle temperature fluctuations, scientists can learn about the conditions present shortly after the Big Bang and test our theories about the universe's origin. These fluctuations provide clues about the formation of galaxies and the large-scale structure of the universe. The CMB has been instrumental in confirming the Big Bang theory and continues to be a vital tool in our quest to understand the cosmos. After the formation of atoms, the universe began to take on a new shape. Hydrogen atoms, the simplest and most abundant element, started to form in the vast expanse of space. These atoms were the building blocks of everything that would come later. And the release of the CMB, a faint glow that permeates the entire universe, providing a snapshot of the cosmos when it was just 380,000 years old. The universe entered a period known as the Cosmic Dark Ages. This era, lasting hundreds of millions of years, was a time of profound darkness and silence. This era wasn't completely dark, as the faint glow of the CMB still lingered, but it was a time before the first stars had ignited. But it was devoid of stars and galaxies, the brilliant objects that light up our universe today. The cosmos was a vast, empty expanse waiting for the first sparks of light, the brilliant objects that light up our universe today. These stars and galaxies would eventually fill the universe with light and structure, but that was still far in the future. However, the seeds of these structures were already sown. Tiny fluctuations in the density of matter, present from the very beginning, would eventually lead to the formation of all the cosmic structures we see today. Tiny variations in the density of matter imprinted in the CMB acted as the initial seeds for the formation of galaxies and clusters of galaxies, created regions with slightly stronger gravitational pull. Over millions of years, these regions began to attract more and more matter, slowly growing in size and density. These regions attracted more and more matter, pulling in gas and dust from their surroundings, causing them to grow denser and hotter. As these regions continued to accumulate matter, they became the birthplaces of the first stars. Eventually, these dense clouds of gas collapsed under their own gravity, igniting the first stars. These stars were the pioneers of the universe, lighting up the darkness for the first time. These stars, much larger and hotter than our sun, were the first sources of light and energy in the universe, bathed the surrounding universe in intense radiation. Their light began to reionize the hydrogen gas that filled the cosmos, ending the cosmic dark ages. They also created heavier elements through nuclear fusion in their cores, elements that would become the building blocks of planets, moons, and eventually life itself. Elements essential for the formation of planets and life itself. As stars clustered together, they began to form the first galaxies, the building blocks of the large-scale structure of the universe. They formed the first galaxies, vast collections of stars, gas, and dust, bound together by gravity. These early galaxies were the precursors to the complex and diverse galaxies we see today. Vast collections of stars, gas, and dust bound together by gravity. Over billions of years, these galaxies evolved and interacted, merging and colliding to create the diverse cosmic tapestry we observe today. These galaxies evolved and interacted, their gravitational dances leading to the formation of new stars and planetary systems, merging and colliding to create the diverse cosmic tapestry we observe today. The universe, once a dark and empty place, had transformed into a vibrant and dynamic cosmos, filled with light, energy, and the potential for life.